Hello students, in this video I will go through the process of proving line segments congruent, very similar to lesson U1A01b. So let's take a look. So in this video we're going to be using capitalizing on the postulate that was introduced in the previous video, which is the segment addition postulate. We are also going to be taking a look at this definition here, which is the definition of midpoint, which is a point that is on a line segment that divides it into two equal parts, or it's the halfway point of a line segment. I don't believe in the two examples that I'm about to go through it uses this. However, this may come up at a later point in another lesson. So keep this in your notes. All right. In the previous video, I've gone through differences between congruence and equality. Again, congruence is where two different shapes are 100% identical in every way, where all the points line up and match. Whereas equality is we're talking about specific quantities regarding the two objects, such as their length and angles as being the same. For our purpose in this course, we are really treating congruence and equality as synonyms for all intents and purposes, because the difference is very subtle for the types of problems that we encounter. All right, so let's take a look. Please take a moment and pause the video and copy down the set of givens here, and we're going to attempt to try to prove this. And what I also want you to do is to construct a two-column, to construct a statement and reason chart like I have here. There's actually only, you don't need 10 lines here, but I've made 10 lines. But yeah, pause the video to see if you can draw all the stuff down and then mark up the diagram. So hopefully you guys had some time to do this. I'm going to, as a standard of practice, always mark up the diagram here. So what I notice right now is Wx is congruent to Yz. So I have this segment over here is congruent to this segment over here. And I am going to put in a tick mark like so. And my attempt is to show that WY is congruent to XZ. I'm going to use another highlighter, a different color highlighter here to demonstrate this. We're attempting to show that this segment here is congruent to this segment here. So the segments that are in pink. And you can see, I hope, like logically, that these two segments have to be equal, because if I use the pen here and mark up this segment in the middle with two tick marks, you're going to see that Wx plus Xy has a total of how many tick marks? I see here I have two tick mark plus one tick mark, right? And then the same thing could be said about segment Xz. Xz is made up of Xy plus Yz. So logically speaking, right, this makes total sense that WY should be congruent to XZ. Well, let's put it in the statement and reason chart and see how we can actually execute how to, I guess, demonstrate these ideas on paper. Okay, so let's write down all the givens. And those statements are true because they are our givens. Now, under, again, there is a small difference, okay, between congruence and equality. For our purpose, I'm going to treat congruence at the same way I would equality. But when I made these slides a couple years ago, I had that distinction in place, which is why you're going to see that there are going to be some lines in the two-column proof that are going to be left blank, because I edited it so to leave out the distinction between congruence and equality. You're going to see what I mean in a moment here. So I'm going to say that xy is congruent to xy, because if you notice when I marked up the diagram, I put in two tick marks here, right? Xy is congruent to xy, and the reason for why that is true is because of reflexive. This is the part where I mentioned a moment ago that where I left out certain lines blank. Well, that's because, again, I made these slides a couple years ago, and I had in lines 4 and 5, I converted things from congruence to equality. We're not going to do that, okay? We're not going to do that, but instead we're going to treat congruence and equality as the same things. So my next statement that I wrote down was, I know that WY, which is what I'm trying to prove congruent to XZ, WY is equivalent to segments WX plus XY, right? And this is true. This does not require any proof. This is true because of segment addition postulate. There's no need for any prerequisite prior statements to state this, okay? Other than that W, X, Y, and Z must be on the same line. If they aren't on the same line, then line 6 would not be true. Again, I'm adding 2 segments that would make up the total length of the segment, and that's true because of segment addition postulate. I can make the same argument with XZ, that XZ is made up of XY plus YZ is equal to XZ. And this is, again, for the same reason, segment addition postulate. Now notice I have in line 1 and line 3, WX is congruent to YZ, and line 3, XY is congruent to XY. What would happen if I were to add lines 1 and 3 together? If I were to add lines 1 and 3 together, I would end up with WX plus XY is equal to XY plus YZ, wouldn't I? Right? Again, I'm adding lines 1 and 3 together. And if I do that, I'll end up with line 8 there. In line 8, that statement is true because I'm adding lines 1 and 3 together to make addition line 1 and line 3. All right, so now if you take a moment, right, pause the video, see if you can figure out what the next statement should or could be to link 6, 7, and 8 all together. Right? Remember, our objective is to prove that WY is congruent to XZ. If you're thinking of substitution, then you're definitely on the right track, right? We can take line 6 and line 7 and substitute it directly into line 8. And how are we going to do that? Well, I know that WX plus XY, which can be found over here, I can replace that with WY. And I'm going to use a different color now. I'm going to use blue. I know that XY plus YZ, which is this guy over here, can be replaced with XZ. So my final statement, therefore, is simply WY is congruent to XZ. And the reason is I am performing a substitution. I'm substituting lines 6 and 7 into line 8. All right, let's take a look at another example. Okay, so in this diagram here, very similar setup, okay? I have line segment Andy. I have AD is congruent to NY. Pause the video for a moment. Let's draw the diagram, write out the givens, write out this statement and reason chart like I have here. The statement and reason chart does not necessarily have to have 10 lines, but I made 10 lines, but you don't have to. In fact, I know for a fact that we are going to use less lines in this, but let's take a look, okay? So hopefully you drew the diagram and have marked up the diagram and have maybe possibly attempted to think about this on your own. Let's mark up the diagram here as I'm going to demonstrate. I know that AD is congruent to NY. I'm going to use a highlighter for this. So I know that AD is congruent to NY. And my goal is to show that AN is congruent to DY. Can you see that this is actually like the opposite of the last problem? In the last problem, we were given the shorter segments on the two ends there, and we're trying to prove the partial segments are going to be the same. Here, we're given that the partial segments are congruent, and we're trying to prove the end segments are the same, right? So we're trying to prove that these two guys here in blue are the same length. Well, how are we going to do that? Well, in a very, very similar manner, right? I know that since AD is congruent to NY, it is always a good strategy to write out the relationship if a certain segment is made up of other segments. So I know that AD is equal to AN plus ND. And this is true because of, again, segment addition postulate. I can make the same argument with NY, that ND plus DY is equal to NY. And this is because of, again, segment addition postulate. So the next part here is where I am going to try and link things together. Notice that AD and NY are congruent to one another. And then I have lines 4 and 5 stating what AD and NY are made up of. The next logical conclusion is to try and link line 1 and lines 4 and 5 together. Or you can think of it as lines 4 and 5. You can think of lines 4 and 5 being thrown into line 1. So I can say AN plus ND is equal to ND plus DY, and this is because of, again, substitution. I am substituting lines 4 and 5 into line 1. And I'm almost in the clear. If you look at this, right, line 6 here is written like an equation. My objective is to show that AN is congruent to DY. And if you notice now, I'm going to use another highlighter color here, that ND is on both sides of the equation. What are we going to do to get rid of this? Well, we're going to say ND is congruent to itself, and that's because of reflexive. And then we're going to perform a subtraction. We're going to subtract lines 6 and 7 to get rid of the NDs on both sides. And if we do, we'll end up with AN is congruent to DY, and that's because we are subtracting lines 6 and 8 together. Sorry, lines 6 and 7, it should say. Let me just really quickly fix that. I should say lines 6 and 7. And that's essentially it. Okay.